So next up, we have Guru Parulkar. Guru is, of course, well known in the ONF community. But for those of you new to ONF, I'll share that Guru is well known for being at the forefront of networking and of SDN. Guru is the executive director of ONF and the executive director of the Stanford Platform Lab. He's one of the leading forces helping to advance an agenda embracing disaggregation, white box hardware, and open source software. And I'll also share, and maybe embarrass Guru, that he was just recently named an IEEE Fellow. So Guru, welcome, and please take it away.
Oh, thank you, Timon, for that kind introduction. Really appreciate it. Hello, everyone, and welcome. And again, thank you all for joining this particular section on private 5G edge cloud. I want to also take the opportunity to thank Andre for an excellent keynote, and more importantly, also thank him for his unwavering support of ONF over the years. Clearly, as the chairman of the ONF board, his strong support has been very critical for the continued success of ONF in its mission. So thank you, Andre, really appreciate it. Okay, now for my talk, I'm going to introduce Aether as ONF's flagship platform or flagship project. It is an open source platform for private 5G connected edge cloud as a service, and it is aimed to accelerate what we call smart enterprise transformation. So let's briefly talk about what we mean by smart enterprise transformation. Sometimes it is also called Industry 4.0 transformation. So basically it involves automation of physical facilities or physical spaces with Internet of Things, connectivity with 4G and 5G, edge and public cloud computation. Okay, so let me take a few examples to make this little more concrete. So for example, Harley Davidson has been building customized motorcycles, and recently they deployed an IoT network for operations automation. And here is the kind of results they reported. They reported that productivity in terms of production time for each motorcycle, which was used to be 21 days, reduced to 6 hours. Efficiency in terms of production costs reduced by 70%. Safety and security in terms of worker injuries went down by 91%. And flexibility in terms of bike variations on a single production line went to 1700. Clearly very impressive results with tremendous gains for the company. Another example is Nokia that has been manufacturing base stations parts. They also deployed an LTE powered mobile private IoT network with edge cloud for operation automation. And here are the results they report. That is, productivity in terms of effective use of machinery went up by 40%, productivity in terms of system maintenance frequency went down by 98%, and efficiency went up by 30%. One final example in this sequence, that is Bosch, that has been manufacturing hydraulic valves, among other things. But for this factory, they deployed an IoT network with edge cloud and operations. And again, they report some amazing results in terms of productivity, efficiency saving, and flexibility. So, and there are other examples like Tesla and even a Stanford hospital. In fact, tomorrow we are going to hear a keynote talk from Christian, who is the CTO of Stanford Hospital, and in the latest, newest hospital, they have put a lot of automation and reporting some amazing results. So if you can, please plan to attend his keynote tomorrow as well. Now, there have been many market studies that have tried to define this market across different verticals and try to understand the role of the enabling technologies. Based on these studies, we can have the following conclusions or following observation. The first one is that smart enterprise transformation represent the biggest infrastructure build out that we are going to see over the next few years. And it is going to provide tremendous growth opportunities for most of the technology sector. Okay. The second observation is that 5G edge cloud with IoT and AI, ML plus AR, VR will be the major enabler of this transformation. Okay. And finally, every enterprise is going to be impacted by this. Most enterprises will use this technology in some or the other form, and many technology companies will be the providers or part of the supply chain in this transformation. Okay. Now, some of these market studies, for example, one from KPMG, have also tried to do sizing of the market. Okay. And across the different verticals and for different technology sectors such as connectivity, software, hardware, and services. Now, the exact numbers are not that important. What is important is that these numbers are big, and these numbers are big across these technology sectors. And that means this does represent an important opportunity for majority of the technology companies as well. Okay, so now I want us to understand one more thing, and that is this market is in nascent state. It is just emerging. Yes, I mentioned that there are early adopters that have realized a lot of big gains with this technology and this transformation. However, as it happens in most of the emerging markets, early adopters employ purpose-built, closed proprietary solution that require a lot of talent in-house in order to deploy it, operate it, and realize the benefit. For this market to realize the full potential and go mainstream, what market needs is a solution that is general purpose, easy to use, deploy, operate, and so on, and of course, be economical. Now, towards this goal, ONF has proposed a solution which is we call Aether, which is general purpose, easy to replicate, hopefully easy to deploy and operate, and also economical. But most importantly, it is also open source. We believe that it is really important for a platform to be open source in this emerging market to create what we and others call an Android effect. So in next 15 minutes or so, I am going to provide a high-level overview of Aether, which, as I mentioned, is an open source platform for private 4G, 5G connected edge cloud as a service with fine-grained measurement, closed-loop control, and network verification. So let me give you a quick overview of Aether and a deployment scenario for Aether in an enterprise. So let's start on the left and imagine an enterprise. This enterprise can be a factory, it can be a smart retail, it can be an office, it can be a hospital, and so on. What is common is most of these enterprises will have different kinds of IoT devices in the form of robots, drones, and other kinds of domain-specific sensors and actuators. Of course, these enterprises will have conferencing facilities with multimedia, many employees and visitors with their own devices. Now, to this environment, we bring Aether as an open source, private, 4G, 5G connected edge cloud as a service. What it requires is deployment of a few small cells. They can be operated over CBRS spectrum or the license band spectrum, and deploying a rack. You can think of that as a micro or nano data center. And this, we call this Aether connected edge. And there are many such ACEs in different enterprises, and they are cloud managed using Aether managed platform. So as far as enterprise is concerned, it is just deploying Aether connected edge and some number of small cells, and they operate it as a cloud managed service. It is as simple as that. Of course, internally, Aether has a lot of sophistication. Okay, it is runs on an SDN substrate with disaggregation and open source SDN substrate, and on top it has a RAN, mobile packet core, and an edge stack. This is the software stack. Now, what is important to realize is that at every ACE, we run what is called a mobile core user plane. And this mobile core user plane at the edge does what is called local breakout. What that means is that we have access to packet stream for a user or an application or a particular flow. And once we have access to this packet stream, we can enable edge computing for that particular packet stream or a packet flow. And so that we can do that edge processing or edge computing in support of the smart enterprise applications or use cases. And that's very important. Of course, the control plane for this mobile core runs in the core as well, in the central cloud. On top of that, we can run a variety of higher level platforms, IoT, machine learning, computer vision, and they enable a whole bunch of edge applications in support of this smart enterprise transformation. So that is what Aether and the rest of the platforms and applications look like in an enterprise setting. Now, Aether itself as a platform or a solution essentially provides three services. Okay, the first service is obviously the connectivity service, 4G or 5G connectivity as a service, and this is for mission critical application that requires higher levels of security, predictable performance, really low latency for this mission critical application. Now, in addition to connectivity, we also provide connectivity with edge computing. And so the idea here is that for many of the smart enterprise transformation, we need connectivity and edge computing hand in hand in order to enable these kinds of applications that are mission critical, requiring low latency and computing at the edge of the platform. And we provide this in a very native fashion on the Aether platform. Finally, we also offer, or we are working on offering what we call end-to-end slicing. So this is slicing across radio access network as well as mobile core. And this is in such a way that enterprise can specify what devices, what application, what flows belong to a particular slice in a very easy to use interface, and then also specify what are the resources required for this particular slice and what are the priority of this slice compared to other slices. And that allows us to provide this quality of service guarantees and performance to these services. And all of these services, as I mentioned, are offered as cloud managed services. So it is very easy for enterprises to consume and operate these services on this platform. Now, as I mentioned, these services have some very important attributes that we enable as part of the Aether platform. First and foremost, the quality of service guarantees and security guarantees in terms of predictable performance, low latency, and higher levels of security, because we are able to leverage the 3GPP's SIM-based authentication and encryption. Another very important attribute of these services is we make the services programmable and customizable for the enterprises using very, very simple interfaces so that they can adopt their services and customize it for their needs. Another feature that we offer is fine-grained visibility. That is, we allow an enterprise to be able to even monitor per packet, do per packet monitoring for an application or a flow, or a per container monitoring for a given application or a particular use case. Of course, we also provide aggregated level monitoring as well as appropriate and as required by the application, but we are able to do this per packet level monitoring, which is very, very important for certain kinds of diagnostics and what we call closed loop control. So we offer a number of programmable control knobs in addition to fine-grained visibility to do what we are calling closed loop control. And this can be used for resource optimization. For example, if you do optimization of RAN resources, radio resources, you can do that using the visibility and closed loop control. Or you can use this closed loop control for troubleshooting. So for example, if there's a misconfiguration of a device or a misconfiguration of a particular control application or a user application, you can do troubleshooting using that. Also, you can use this fine-grained visibility with closed loop control for security. For example, mitigation of a DDoS attack. And finally, we are also working on providing verifiability. What that means is that we can verify for every packet if that packet is forwarded according to the intent of the enterprise or intent of a application that is this packet belongs to. So that is the level of verifiability we want to bring to this infrastructure. Now, all this becomes possible because underneath Aether, we are using some innovative, state-of-the-art technologies. For example, at the networking substrate, as I mentioned, we use SDN with programmable forwarding that provide lot of dials, programmable dials for the visibility on one side, and a number of programmable control knobs using which you can program and control the behavior of the system and behavior of the application, for example. Another thing is we use cloud native computing and containerization for all the software, including the lowest level networking control software, as well as all the other higher level software we run that is containerized and cloud native. So you can run it very flexibly, and it becomes part of our CI/CD infrastructure as well, so that we can upgrade it in a very seamless fashion in a real operational network. So for example, when you look at our RAN implementation, on one hand, this is obviously based on ORAN specification, but this RAN implementation uses SDN with programmable forwarding as well as cloud native computing to get all the benefits of that. And similarly, the mobile packet core, it again uses 3GPP's CUPS compliant specification. However, it is also based on SDN and disaggregated and uses cloud native computing as well. Okay, so these are the foundational technologies that help us create this new capability that we can bring to the private 5G connected edge cloud. Now, Aether, as I mentioned, offers these three services, and in that sense, it is a solution in its own right. But it also serves as an open source platform that can run on a diversity of hardware. Right now, we run primarily on Intel and Broadcom hardware, but we are trying to see how it can we can demonstrate this platform on other kinds of hardware as well. Okay, and on top of that, it is designed to support multiple platforms, the higher level platforms, the AI/ML platform or IoT platform or computer vision platform as an example, enabling a whole bunch of application in support of the smart enterprise transformation that we are all talking about. Okay, so I think at this point, you must be wondering that this is all well and good, but what is real? What is working, where we are in this particular journey? So what I'm going to do is to spend the next few slides or next few minutes trying to give you a quick update on where we are in terms of the status of Aether. Okay, so the first thing is, let me start with the fact that Aether has been operational in a pilot setting since December 19, so almost a year. Now, I want to emphasize that this is a pilot setting, so it is not something that is supporting real users and production users, but in a production setting. Now, as I mentioned, it is a cloud-based managed service. So we use Google Cloud and all our control and management software is running off of Google Cloud. And we have implemented or deployed Aether edges at, of course, our own locations in Menlo Park in California, Tucson in Arizona, but also in Intel labs in Portland, AT&T labs in Atlanta, Siena's 5G testbed in Montreal, Canada, Telefonica lab in Madrid, Turk Telecom in Istanbul, and then NTT in Osaka. So this is where we have Aether edges operational, and we manage them and offer them as a managed service from a central location where we are running our software in Google Cloud. Very soon, and by very soon, I really mean in next couple of weeks, we are bringing up 5 more Aether edges into this particular infrastructure. Two of them are going to be at Stanford, one of them at Cornell University, and another one at Princeton University. And this is part of a DARPA-funded project called Pronto, and I will talk about that in just a minute. But this is kind of our deployment as of this month that we are operating. Now, let me quickly tell you about few applications and higher level platforms that we have demonstrated on top of Aether. Obviously, the first thing is the connectivity as a service. This is the most important service that we need to support. And so anything that is CBRS or 4G enabled device, we are able to connect it to Aether and be able to provide connectivity as a service on that device. But in addition to that, we have also implemented applications and some platform. So for example, one application we implemented is object identification application, or rather we demonstrated this application in close collaboration with our collaborators running the IoT, Azure IoT Edge platform. And so this is one example application. Another application that we have demonstrated is what we call smart spaces, okay, where we run this application to identify number of people in a given space and the occupancy detection. Again, it uses an AI ML platform that runs at the edge, also in the cloud, and then application is running at the edge in the cloud as well. Another one is a homegrown CDN application that we demonstrated on this platform as well. And most recently, we have been collaborating with Google Cloud, and we have demonstrated this, what we call person detection application, that is, again, is using Google's AI ML platform that is running on Aether. And also we are using Google's Anthos platform in order to orchestrate, manage this particular application running on Aether as well. Okay, now, in addition to running this application, as I mentioned, we are operating Aether as a distributed infrastructure with close to 10 Aether edges that are deployed. And so as a kind of a service provider ourselves, we also operate what you can think of that as an operation center or kind of centralized management system. And here is an example of a dashboard where you can see that we are able to monitor different edges, what is the uptime, whether the control plane, user plane, all of this is up and running as well. Now this is the higher level dashboard, but we also have a very detailed dashboard where you can see for a particular pod, what is the CPU memory and the pod utilization is for a given cluster, and you can observe that. In fact, you can go another level deeper where you can look at different containers, their network usage, their CPU memory utilization, and all of that when you're trying to diagnose problems and so on. So this is kind of the operations platform that we are using in order to kind of operate and manage this distributed infrastructure. Now, we are also in the process of building a dashboard, or you can call it a portal for enterprise, so that they can also monitor themselves how well their edge is behaving, either in terms of services or in terms of the devices and so on. And obviously, we want to give this visibility to enterprises, but the hope is that as the cloud based managed service operator, we should be able to diagnose the problems and be able to address the problems even before the enterprise realizes them. And that is the goal, and that is the process. So this is not functional yet, but this is where we are headed as we continue to mature this platform going forward. Okay, now let me take a minute to tell you about a brand new project that is very closely tied to Aether. It is a project that is funded by DARPA. We call that project Pronto, where DARPA has decided to give us $30 million funding to build, deploy, and operate a production-ready Aether with fine-grained measurement, closed-loop control, and network verification. This is a project in collaboration with 3 universities and ONF, Cornell, Princeton, and Stanford. The universities are primarily focused on doing research on fine-grained measurement, network verifiability, and closed-loop control. But these are all very systems oriented researchers, and they are doing this research on top of Ether. And ONF's role is to provide a production ready Ether as a platform or an operational network, and integrate the research results coming from these universities as part of our platform or as part of our solution. And we are just 6 months into this project, but this is a very exciting project, and it is going to be quite impactful as we go forward. Now, I have a treat for you all. That is, the good thing is that you have an opportunity to hear from some of the leaders of Pronto and the leaders of this field. For example, Nick McEwen is going to give a keynote talk tomorrow, where he will provide the overview of Pronto project. But you can also listen to Jen Rexford, who is doing some amazing work in closed loop control, and Nate Foster, who is doing a lot of great work in network verification. And their talks are available on demand on the web, and hopefully they are going to go online today. So that is something you can listen to as well. And now, I was only able to give a very high level overview of Ether today. However, there are two more talks that are going to happen tomorrow and day after. That is from Oz and Larry. These are the two people at ONF that are actually leading the Ether project. And they will get into a lot of details on all aspects of Ether. And so please make sure that you are able to attend their talks and get more information about Ether. And of course, there is an Ether website that you can go to. There's a lot of collateral and there is a lot of information available there as well. Now, the Ether ecosystem, obviously, we are very, very grateful to our ecosystem. You can see that we are working with the telecom operators, obviously AT&T, Deutsche Telekom, NTT, China Unicom, and so on. We are also working with cloud operators, specifically Google, that we are very grateful for. Then there is the whole technology companies like Intel, and there are many companies that are very active in the RAN, ORAN, and the RAN implementation, as well as in the edge cloud space as well. So in conclusion, let me again summarize that we believe that smart enterprise transformation represents a huge opportunity for the next so many years. And in support of that, we are trying to bring Ether as an open source platform for private 5G, 4G connected edge cloud as a service. And there are many innovations that are at the heart of Ether, and they can be divided into two parts. There are some innovations that are related to 5G, disaggregation, and how we use cloud native computing and cloud-based managed service. And then there are another class of innovation that have to do with SDN with programmable forwarding, that is allowing fine-grained measurement, closed-loop control, as well as network verification. And we do all of that on top of open source COTS hardware. Now, all of these innovations lead to a number of benefits for an enterprise, okay? In terms of, this is the right platform for mission critical use cases or mission critical applications. There is a compelling economics because of these innovations and how we build this platform. This is highly secure because how we are taking advantage of 3GPP standards and cellular technology. But in addition to that, we are taking advantage of SDN and network verification and closed loop control. Then we are allowing enterprises to control their own destiny by providing top-down programmability, fine-grained real-time measurement, innovation in production network, and we are allowing enterprises to own their own data, so they don't have to ship the data into public cloud if they choose to. They can keep the data on site with the edge platform and edge cloud. And finally, we want to, we are designing this platform to enable a diverse application. So one more thing, we are very optimistic. You can see all my excitement here. We believe that, we have all the right elements to be able to have an impact. So first of all, a very compelling mission, as I mentioned, as Andre mentioned, and you will hear that in this event, that this is something really, really important. The private 4G, 5G connected edge cloud as a service is a very important for smart enterprise transformation. We have a very, very good team. Of course, ONF is now 40, 45 people, and very strong group of developers and architects. But we are also complemented with our ecosystem. We are working with some of these companies that I mentioned, and we are very grateful for the same. And we are collaborating with Cornell, Princeton, and Stanford, where we have access to some of the leading professors, postdocs, students, and we are working with their campus IT as our customers or users as well. Our platform is based on ONF's proven platform that are already used in production setting in some cases. And of course, we have a pretty good funding for the next few years from both DARPA and this ecosystem of companies that we work with. So because of all of this, we believe a number of things are coming together for us as a community to deliver on an open source 4G, 5G connected edge cloud platform, and that can be pretty exciting. So I hope based on all of this, you will decide to join forces and we can work together. So for example, if you're an enterprise interested in smart enterprise transformation, happy to explore Aether connected edge deployment for proof of concept or trial leading to production deployment. If you are an ecosystem partners in the supply chain, if you have an IoT platform or machine learning or AI platform, happy to see how we can integrate that with Aether and demonstrate it there. Happy to port Aether to your hardware or software platform. So happy to work in this context. If you're a university or you have a campus, we will happy to support an Aether connected edge deployment for your research and campus automation. So this can be similar to what we are doing with Stanford, Princeton, and Cornell, and we can try to replicate that in your university. And if you're an open source developers, not attached to any one of these organizations, we would love to get your help and help you make significant contributions to a significant project. So I think with that, I want to thank you for listening and participating in this event. And Timon, back to you. If you have any questions, happy to take them.
Good, thank you, Guru. Well, questions we do have. We've been getting a sort of a flood of questions, and I'm trying to organize them, and we have a little bit of time, so I'm going to dive right into it then. I think there were a class of questions, and Shaylin and AJ were asking, why not use Wi-Fi, Wi-Fi 6, public 5G? Why would enterprises choose to use private 5G?
Oh, very good. I think that is a very good question. That question gets asked very often. So I think you must have heard me say many times, and Andre said that in his introduction, that if you have this smart enterprise class of application, that you can think of that mission critical application. These applications require certain quality of service guarantees. They really want predictable performance. They want higher grade of security, and they want to be sure that there is no interference. With Wi-Fi, even with Wi-Fi 6, all the innovation that is going on, it is an unlicensed band spectrum, and its architecture is such that providing non-interference quality of service guarantees is extremely difficult in that context. So that is the reason enterprises are going to consider using 5G in this context. And I should also mention that what we are doing with Aether and other people are trying to do is they want to give you 5G, but with Wi-Fi kind of economics and Wi-Fi like ease of use. And so maybe there is a best of both coming together with these kinds of solutions that we are trying to develop.
Very good, thank you. Also a class of questions around what Aether is built on. Is it built on OpenStack? And what hardware is running Aether running on?
So I think it's not built on OpenStack. As I mentioned, everything is containerized. And so we use Kubernetes, and Kubernetes on bare metal is what we are using as far as the underlying software is concerned, and of course on Linux. And as far as hardware is concerned, there is the networking silicon is Broadcom and Intel. when we talk about programmable forwarding, we are taking advantage of Intel's Tofino chips. When we have a version of Aether where we are taking less advantage of programmable forwarding, we have a version of Aether working on Broadcom silicon as well. When it comes to servers, it is primarily Intel so far. We have used NVIDIA GPU for acceleration in certain contexts. And then when it comes to base stations, we have tried multiple base stations from Acceleron, from Circom, from Bicell. So those are the kinds of base stations that we have worked with for small cell.
Terrific. So another question, what's the reason for using Google Cloud? And from Amish, can Aether management run on Azure, AWS, or is it only on Google Cloud?
Oh, very, very good question. Actually, you know, I mean, we have demonstrated Aether central thing running on Azure, AWS, and Google Cloud. But when we decided to go for production, our kind of production, which is the pilot network, that we are running out of Google Cloud because we need to have something, and we have a great relationship with Google Cloud. So for that, we are running it out of Google Cloud. However, we have demonstrated it on Azure as well as on AWS as well.
Very good. So then a class of questions around licensing and open source. So Laurent asks, what's the license? And an anonymous user asks, when is it released to open source?
Very good. So I think what I can commit to you is that ONF, as part of its bylaws, is going to release all of this in open source under Apache 2.0 license. Our board, maybe 3 months ago or 6 months ago, I'm forgetting the timeline, decided that it is in the best interest of the project and in the best interest of the partners that during this incubation phase, it remain under what we are calling member-only license. So right now, Aether is under member-only license, but the commitment is to go and open source it to Apache 2.0 when it is matured and it has achieved certain level of critical mass and momentum.
Good. So a question about, can you throw some light on how AI and ML would be used with Aether? And
so for us, AI and ML are like the higher level platform that are going to take advantage of the service that Aether offers, which is 5G connectivity with edge computing. Okay, so for example, if you look at this person identification application, typically what happens is that the inference part of this application and that AI ML is done at the edge. The learning part is done in the public cloud, which requires a lot of data, lot of computing and all of that. So that, and it's not time critical. So that you run in the public cloud, and the inference part of it that requires low latency and you want to react quickly, that you run at the edge. And that is what you run on top of Aether, taking advantage of Aether's connectivity with edge computing service, and that you layer it on top of that. I hope I'm answering that question.
yeah, I think so.
Okay.
And so let's see. Stephen's asking, so is maturity less than 1 year away? Question mark. So how mature is Aether?
I guess it depends on what maturity means to you. If you want to do POCs and you want to do trials, I would think by end of Q1 2021, it will be mature enough to do POCs and trial and all of that. If you want to run a factory using Aether, I think it may be at least 12 to 18 months away before I can, and again, it will require significant hardening and, kind of testing and all of that before I would suggest anybody run a factory using Aether. But trial and POC, we will be ready to do that end of Q1 2021.
Okay, very good. And so we just have 3 minutes left, and we have a whole class of questions around Open RAN and ORAN and the SD-RAN work. So, which is part of Aether, as you were explaining. So there's a question around, is there any collaboration between ONF and the ORAN software community? And what's the relationship between ORAN and Open RAN? Maybe you could bundle those into an answer.
Oh, so I think, as Andre mentioned as well in his keynote, that ONF has a pretty close collaboration with ORAN Alliance, and we are actively contributing to specifications and some of the architectural extensions to ORAN with a group of operators and with our ecosystem to ORAN Alliance. So we have a very good relationship with ORAN Alliance in that sense. We are also starting to work with ORAN software community. And there is one specific project where ONF is taking the leadership, that is development of an SDK that is going to help make the X app that run on top portable across multiple RIG platforms. So we are of course building a micro ONOS based RIG platform, which is doing really great. But on top of that, we are also now building an SDK that will enable portability of X apps across multiple RIG platforms. And we are doing that work, or starting to do that work in very close collaboration with the OSC. So yeah, so these are all communities working together, and ONF is working closely with ORAN Alliance and ORAN OSC.
All right, very good. Really, we do have a lot of other ORAN related questions. We're not going to have time to get into them. I think there's one interesting one though that maybe you would hazard to answer, which is around licensing. It's, why not select a more 3GPP compatible license than Apache 2.0? Maybe this would attract more of the 3GPP community to ONF's work.
Oh, I guess that's a good comment and a good question. I would love to follow up offline to understand what that means and whether our board is open to that idea. As I mentioned that when Open Networking Foundation was created almost 10 years ago, we had put this into our bylaws that we will open source everything under a liberal license like Apache 2.0. But if it helps the industry and that is the right thing to do, I'm pretty sure the board will be willing to consider some other option, and love to hear more about it offline, and we can discuss that.
Good. Well, with that, we're going to switch gears now. But Guru, thank you very much. And
Oh,
thank you, everybody. Thank you for the questions, and sorry we couldn't get to all of them, but I would point people to more resources on the ONF site for the Aether project and the Aether website, and for the SD-RAN project on the ONF site as well. And we will